In this video, we are going to discuss about transient response of RL circuit to sinusoidal excitation. To analyze the response of RL circuit to sinusoidal excitation, let's consider the circuit which is excited by a sinusoidal voltage source having value Vm sin omega t. At t is equal to 0, the switch is getting closed so that current I of t will flow through the circuit. Let's see how to solve this circuit in normal method other than transforming into S-domain network. Here the KVL equation for the circuit at t greater than 0 can be written as Vm sin omega t is equal to I of t into R plus L into di by dt. Let it be equation number 1. As switch was initially in open condition, initial current is 0, that is I0 is equal to 0 ampere. Now we can take Laplace transform of equation number 1. Laplace transform of Vm sin omega t become Vm into omega divided by S square plus omega square, which is equal to I of s we can take common, I of s into R plus S into L. Further simplifying, we can write down the expression for I of s as omega into Vm divided by S square plus omega square into R plus SL. This S square plus omega square can be written as S plus j omega into S minus j omega. So we can write down I of s as omega Vm divided by S plus j omega into S minus j omega into R plus SL. From this last term, we can take the coefficient of S outside. So it become L into S plus R by L. So the final expression for I of s can be written as omega Vm divided by L all divided by S plus j omega into S minus j omega into S plus R by L. This I of s can be solved by taking partial fraction expansion. So I of s can be written as A divided by S plus j omega plus B divided by S minus j omega plus C divided by S plus R by L. Here we can obtain A as by multiplying this equation with S plus j omega and equating into that S is equal to minus j omega. Similarly, we can obtain B value by multiplying this equation with S minus j omega and equating S is equal to j omega. And finally, we can obtain the value of C by multiplying this equation with S plus R by L and equating the value of S in that equation as S is equal to minus R by L. So if we are doing like this, we can obtain the value of A as Vm divided by minus 2j into R minus j omega L, B as Vm divided by 2j into R plus j omega L, and finally the value of C as Vm into omega L divided by R square plus omega square L square. Now we can substitute the value of A, B and C in this equation so that we can find out I of t by taking L inverse of that equation. So when we are substituting the value of A, B and C in the equation for I of s, the equation become like this. Now we can find out L inverse in order to find out I of t. So from this equation, when we are taking the first term, this coefficient A can be written as Vm into, when j is going upward, it become minus j, and this minus 2 is already there. So totally it become j Vm divided by 2 R minus j omega L. So 1 by S plus A, L inverse is e raised to minus at. So when we are considering that form, this L inverse become j Vm divided by 2 into r minus j omega L e raised to minus j omega t. Similarly, this j is going outside, it become minus j Vm divided by 2 into r plus j omega L e raised to j omega t plus Vm into omega L divided by r square plus omega square L square into e raised to minus r by L t ampere. So this is the solution. Now let's see the further simplification of I of t. So when we are considering the first term, we can multiply both numerator and denominator by r plus j omega L. So this part become like this. And similarly here we can multiply both numerator and denominator by r minus j omega L like this. Then this term, there is no change. So when we are taking Vm by 2 into r square plus omega square L square outside, this remaining part become j into r plus j omega L into e raised to minus j omega t minus here minus j r minus j omega L e raised to j omega t plus this term retained. So we can have this relation sin x as e raised to jx minus e raised to minus jx divided by 2j and cos x as e raised to jx plus e raised to minus jx divided by 2. And in RL series circuit, the impedance is R plus jXL, that is R plus j omega L. Corresponding impedance triangle is this one. So if we are converting this impedance into magnitude and angle like this, the magnitude is root of r square plus omega L whole square and angle theta is tan inverse omega L divided by r. So from this triangle, impedance triangle, we can write down the expression for sin theta as opposite side by hypotenuse, that is omega L divided by root r square plus omega L whole square. Similarly, we can write down cos theta as adjacent side divided by hypotenuse, that is r divided by root of r square plus omega L whole square. These things are required for further simplifications. So from this part, if we are taking minus jr common like this, so minus jr into e raised to j omega t minus e raised to minus j omega t will come. Similarly, when we are multiplying j into j, it become minus omega L into e raised to minus j omega t. And when we are multiplying minus j into minus j, that become minus omega L e raised to j omega t. So when we are taking this minus omega L outside, this equation can be written as e raised to j omega t plus e raised to minus j omega t. When we are comparing this term with this term can be write in terms of sine and this term can be write in terms of cos. And this is the remaining part, that is exactly same as earlier. So when we are converting this part in terms of sin omega t, it become 2j into sin omega t, that is minus j r into 2j sin omega t. And this part we can write in terms of cos omega t, that is 2 into cos omega t. So here we can take 2 common, so that 2 and this 2 get cancelled. Further simplifying, we can obtain the relation as Vm divided by r square plus omega square L square. So this minus j and plus j, that is become 1. So r into sin omega t minus omega L into cos omega t plus this part. As we seen in this impedance triangle, sin theta is omega L divided by root r square plus omega L whole square. From here we can write down equation for omega L as root of r square plus omega square L square sin theta. And similarly cos theta is equal to r divided by root of r square plus omega L whole square. So from here we can write down the expression for r as root of r square plus omega square L square cos theta. Therefore, I of t can be written as Vm divided by r square plus omega square L square. R we can substitute like this, that is root r square plus omega square L square cos theta into sine omega t minus omega L we can substitute like this, that is root r square plus omega square L square sine theta, and in this part we can substitute omega L as like this. So after simplifying, this and this will get cancelled, so the remaining part become Vm divided by root r square plus omega square L square into sine omega t cos theta minus cos omega t sine theta plus, here also these two part will cancel, this part become Vm divided by root r square plus omega square L square into sine theta e raised to minus r by L into t. So this is the final expression which we got, that is I of t is equal to Vm divided by root r square plus omega square L square into sine omega t cos theta minus cos omega t sine theta. So this part is equivalent to the expansion of sine a minus b. We know the expansion of sine a minus b is sine a cos b minus cos a sine b. So here corresponding to a we can have omega t and corresponding to b we can have theta. So comparing with this, we can write down this part as sine omega t minus theta and this part as exactly similar. So the final expression for I of t can be written as Vm divided by root r square plus omega square L square sine omega t minus theta plus Vm sine theta divided by root r square plus omega square L square e raised to minus r by L into t. This much ampere. So from this equation, the first component of I of t is steady state component and it lags behind applied voltage by an angle theta, where theta is equal to tan inverse omega L by R. The second component is transient components which decays exponentially to 0 with a time constant L by R. In this derivation, we considered Vt is equal to Vm sine omega t, which is 0 at t is equal to 0. But in actual scenario, the voltage function can be at any point at t is equal to 0. That is, at the instant of closing the switch, voltage may be any value. So in general case, we can return V of t as Vm sine omega t plus phi, where phi can have any value from 0 to 2 pi. Then corresponding current can be expressed as I of t is equal to Vm divided by root r square plus omega square L square sine omega t plus phi minus theta plus Vm sine phi minus theta divided by root r square plus omega square L square e raised to minus r by L into t ampere. Here it is to be noted that the transient term becomes 0 when phi is equal to theta, and it become maximum when this part become pi by 2.